Welcome back, folks. So I gave you this as an assignment, but however, I've also done it for you so that we can actually go through this one together. What I've done in this circuit, as you can see, is I have an LDR, but I've also added the LED, something that I asked you guys to do. So in this one, as you will see, as I'm going to cover this LDR sensor, you can see that the LED stopped working. And the moment I remove that, you can see that the LED comes back. Magic. Not really, just science and coding and programming. Now, I'm going to also add a little bit more light to this. And you can see maybe it gets brighter, maybe not. For this, we have the computer to actually give us the exact values instead of relying on our eyes and this camera to be able to figure out whether it's getting brighter or darker. So let's jump to the screen. This once again is the circuit. So as you can see, everything else remains the same, and now we've added a new LED right here. This LED is connected one side to ground and the other side to pin D9 on the Arduino Nano. Let's hop to the Arduino IDE. Over here, once again, we first set up variables. The variables over here, LDR pin is equal to A0. So A0 is going to be called LDR pin. That's where the input is coming from. LED pin is equal to 9. This is where the LED is connected, as we earlier decided. LDR value is equal to 0 and LED value is equal to 0 in the beginning. So it's just nothing. Then after that, I'm going to set up the void setup. Over here, once again, I'm going to set up the serial begin 9600. I'm telling the computer, communicate with me 9600 times per second from the Arduino microcontroller. After that, I have gone ahead and set up the void loop. The first thing in the void loop is the LDR value. So once again, this is the same as last time. The LDR value is the analog read from the LDR pin. So it's basically getting the analog value from the LDR pin, which is once again equal to A0. So it's getting the value from this guy and printing it at the bottom. LED value is equal to the LDR value divided by 4. Okay, now let's talk about this for a second. Why is the LED value equal to the LDR value divided by 4? The LDR value has a range from 0 to 1023, as it's an analog input that it's coming from. With me so far? Because that's connected to the analog input, and that's how much your Arduino can get. As an input device, you can get a 10-bit input into the Arduino, so 0 to 1023. And your output, which is the LED, is connected to the PWM. If you remember, we did this earlier as well, digital output. And over here, your range is between 0 and 255, which is an 8-bit processing of the output. So your Arduino is giving an output as an 8-bit processor, but it's taking an input as a 10-bit processor. So your range for the input is between 0 and 1023, but your output is only between 0 and 255. If you don't follow me completely, don't worry, we'll try and explain this in more detail in the course document, or your mentor can also explain it to you. But what you need to understand is, at the end of the day, this LED is only going to get a voltage between 0 and 5 volts. The max voltage that this LED can get is 5 volts, and that's going to be as bright as it gets. If you go beyond 5 volts, it's going to blow up, and we already did that experiment at the beginning of this course. We already blew up some, so I'm not going to blow this LED again. But what I'm saying is, the computer has to give it values between 0 and 255, but that's relating it to between 0 and 5 volts. That's about it. It's just the numbers that we're playing with, which is the output numbers and the input numbers, but the range is actually, at the end of the day, between 0 and 5 volts always, because that's the limitation that we have with the Arduino over here in terms of power. The next line of code after the LED value divided by 4 is analog write 9, comma, LED value. What that means is we're telling the Arduino that we're on LED, on pin number 9, we're writing the value of the LED value. So whatever value we got over here on line number 12, which is the LDR value divided by 4, I want you to send that value to pin number 9 to light up this LED. That's what we're doing. That's how this LED is getting voltage. Next, serial print LED value. So this is what is coming at the bottom in our serial monitor. So once again, LDR value, serial print, LDR value. So over here we are asking it to call this variable, which is the LDR value that we're getting from the LDR pin. And over there the value is between 20 to 21, somewhere over there, 19 to 21. That's the ambient one. The moment I turn on this torch and bring it closer, you can see that this number starts going haywire and we're getting increasing and increasing and increasing and increasing. Okay, and look at what's happening to the numbers right next to it as well, which is the LED value. Serial print. Now let's look at the LDR value, and over here is the LED value. The next thing that we can read over here is serial print LED value and serial print LN LED value. So once again, we are asking it to print the value of how much power is going to the LED right here in the next line. That's what we did. And we added a short delay of 200 milliseconds. Once again, you can change that to 500 or 1000 or whatever you like, however your brain likes to process this data. If you like to process it really fast, you can remove the delay completely. Or if you want to take your time, just like me, because I'm a bit slow, 500 milliseconds is good. Cool. I hope this makes a lot more sense. Now, try the other tasks. Try make this into a night lamp. Try attach the RGB LED instead of this red LED and have some extra fun. Make your room light up, maybe add a mood light to it. You can also add a few more things if you like. There is a buzzer and a few other things in your kit that you can play around with the same LDR sensor. Go, give it a shot, have some fun, and wherever you get stuck, reach out to your mentor or the community groups and have a chat.